Hey, welcome back. So Google has just released a reasoning model on their AI Studio, and it's called Google Flash 2 Thinking in experimental mode. And oh my goodness, it is incredible. This is the first model that gives us multimodal reasoning, and it is as cool as it sounds. Now, don't get me wrong, it's also great at math, it's great at coding, but the ability to just upload an image and have it reason on the image is just incredible. But there are a few catches and flaws, as I'm going to show you in this video, on why you may want to use text over images in certain cases. And with that in mind, let's get started. Okay, to get started, all you need to do is go to aistudio.google.com. You, of course, will need a Google ID, sign up there. And the good news is that at this stage, there's no cost for actually interacting with the model. But to get started, the big thing you want to do to get access to the thinking model is click on model here on the right-hand side. And you see you've got things like Google 2 Flash Experimental. That's not the model you want. You want to scroll down and preview and pick Google Gemini 2 Flash Thinking Experimental, and then that's what's going to give you access. One of the benefits of reasoning models or inference time compute models is their ability to do math. And actually, I like to give it a problem that I know that the base model isn't going to be able to solve. So in this case, I'm giving it a fairly simple sum, which is 254 multiplied by 752 minus 3 plus 2 minus 7 plus 5. So we'll just kick that off, and the answer we should be getting should be 191,005. And again, you see it's going into thinking mode there. It takes 5.4 seconds. This is a fast model. And then you see the answer is correct, 191,005. Now, the key thing about this is I don't need to give it instructions like step by step. It should do PEMDAS on its own and then work that out and come back with the final answer. Now, if I was to ask the same question of the Google Gemini 2 Flash Experimental mode, exact same question, and then I just run that, you see it's going to do the PEMDAS there, but it comes back with the wrong answer, and that's probably one of the major differences with these inference times compute or reasoning models, is that they take the time to think about it, they emit those chain of thoughts a little bit better, and they work it out and they get the right answers. So you see already sort of better model, but that's not what we want to do. We want to be working with multimodal. So what we are going to switch on to is we're going to switch back into Flash Thinking Experimental. And what we are going to do is we're going to give it a math worksheet here. So what I am going to do here is I'm just going to take a photograph of these questions 17 to 22. I have the answers back here as well, so I don't need to work it out. So I'm just going to type in the prompt, solve the following problems, and then I'm going to paste in my image. And as you can see there, it is the exact same image that we pasted 2 seconds ago there. And again, it's going to go off and do its thinking there. It's going to take a few seconds. So in this case, it has done 10 seconds of thinking. But you see here are the solutions to the problem. Susie's marathon time. Answer is 3 hours and 15 minutes. We'll remember that. The Earth travels at 666 miles an hour, 1.6 miles per day. The time difference for Neil's journey is 18 minutes. So if we just look at some of these answers here, we're not going to sort of go through the calculations. But if we look here, there's the answer, 3 hours, 15 minutes, 1.6 million, Neil was quickest at 4.5 hours. Difference was 18 minutes. Remember, that's exactly what it said there. Number 20, Mr. and Mrs. Dunn's commute. So in this case, it should be Mr. Dunn arrives first, and the time difference should be 3 minutes. So if we look at the answer there, Mr. Dunn takes 1.35, Mrs. Dunn takes 1.4, Mr. Dunn arrives first by 3 minutes. It is literally just walk through the questions. I didn't need to type it out. I just uploaded a math sheet and it did the math. This is so cool. There is nothing to compare this. Now, I'm sure that at some point O1, etc., and DeepSeek and all that will put their multimodal version of reasoning. But at the moment, it is just great to be able to put in these problems and answer it. Now, there is a few other things that I want to point out, which is quite different from, say, the O1 model, which is you actually get to see the chain of thought that's going on there. You get to see the thoughts, the thinking. Whereas in O1 mode, you get a summary version here. It's actually breaking down its thought process, understand the goal, individual problem analysis, etc. And then it's working through each of those problems. And then here's the key thing here, the big difference, self-correction, right? So it goes back over its answers and then checks that it's okay. So this is awesome stuff. Multimodal reasoning. So cool. And it's not just textual problems that it's able to solve. So if I actually look at something like coding, this model is great at math. I'm not going to go through all the kind of math reasoning checks that we would do on other videos. Quite frankly, all of these models are pretty much as good as each other on math. So, I'm not really going to check it in that sense. But what I am going to do is going to show you something cool with images. So I am going to open up, I found a C Lab worksheet here. And then what we are going to do here is we're going to pick one of the loops here. So we're going to pick this one here, which is this for loop over here. And we're going to take this image here and we're going to paste it in and we're going to ask it to generate the code. So in this case, I'm going to come back into my Google AI Studio and I'm going to say create the code for this in C. I'm going to say use for loops, because I don't want it to use while loops or anything like that. I just wanted to use for loops. So I'm going to paste it in. There's the image exactly that you saw a second ago. And let's see what it comes back with. Alrighty, so we just take a look at the moment there. You can see it's created a C code. It's got a for loop. I is equal to 2. And then it's doing a check if I is less than equal to 6. To be honest, it could probably do a little bit of better encoding here. We could just have the I is less than 6 over here and have the I plus 2 up in the for loop as well. But that's fine. I think that's okay. And then you see it's given an explanation of that, and the output of the code is 9. Now, if we compare this to over here, there's the for loop a little bit more terse. For I equals 2, I is less than 6, I plus 2, there's the print there. I could actually just turn around and say, make this code more compact. And there you go. It's given a little bit more of a compact version there. And I think this is one of the things to sort of be aware of when you start to work with the images. Because you're working with image embeddings at that point, it's going to be a little bit more literal in this case. So you might still want to follow up with a follow-up prompt there. But I think, it's done a great job. How cool is that? You can take pictures, you can take diagrams of code and then paste it in and get it to convert it into code. I mean, this is sort of game-changing stuff. Now, that's a pretty good demo in itself, but a little bit later in the video, I'm going to show you how good it is actually at coding, and it really is comparable to the other frontier models. So we'll get to that a little bit later on, but I want to continue on with a couple more image type examples, and we're going to move on to some puzzles. So we are going to do some Tic Tac Toe. Now, normally when I do a test against a reasoning model with Tic Tac Toe, I will give it the puzzle in textual form in ASCII R, and then I ask it to solve it. But the cool thing is with Gemini Flash, I can just give it a picture. So earlier on, I drew a picture of a Tic Tac Toe board. And obviously I took a photograph of that, so we're going to ask Gemini Flash Thinking if it can work out what O's next best move is going to be. So we'll just type in what's O's next best move. I'm going to paste in the image, which again is the exact same diagram that I showed you 2 seconds ago. And there you go. You can see O's next best move is to place their mark in the top middle square. So here. Now I want you to start noticing the problems with this, because I pasted in that image here with an O, an X, and an X. And you see the board that it's produced? It's not the same board. It's got the answer wrong. It's misinterpreted the question. And this is one of the problems with the multimodal reasoning in this sense, that it doesn't always get the images quite right, or even if it does, it doesn't quite reason as well as it would if it's textual. So you can see here it's given this move, but it's got the board completely wrong, and then it's came back with the wrong answer. So that's just something to be aware of there. Whereas if I ask the exact same question, but this time I use ASCII R, you can see that it's came back, it's done a lot more reasoning, it's sort of worked through all the various positions, etc. And then it came back with the final answer is 9. And unfortunately, that's the wrong answer, because by putting the O there, then the X can block the move here. And then they've got this kind of forky thing going on, and then it's going to win regardless of what happens. So ideally, they would have went into position 5 there. Now, if I ask the O1 models for a second, and I'll even ask the O1 mini model, the same question is going to get the position 5 as the right answer. And there you go. Player O should place their mark in position 5. So although Gemini Flash is awesome, I would say in some of the puzzle games, it's not quite as good as the O1 models, but that multimodal capability is just rocking. And again, even in the text mode, even though it's got the chain of thought slightly wrong there and it's came to the wrong conclusion, it is thinking more and it did understand the question better over the image models. And you can kind of see this as well. I put in today's Sudoku, so I said solve this puzzle, and then we'll paste this in. And there you go. It's taking about 40 seconds. But again, if I were to look at this, this is the original board. I want you to see 746 there, and then 3894. Look at this one here, 3894. But if we come back into the solved version of the puzzle, that's the 7-8 there, 3894. Notice what I'm saying there? The 9 and the 4, 3894. So it's actually lost track of the board there. So it's never going to solve that. So even if it was the correct solution, it's just never going to solve it. So if I say validate this and then run it, you're going to see it's going to come back and then it's an invalid solution. Now, what is great about this, for a validation perspective, it is doing the right chains of thought. So you can see it's actually checking, it's going row by row, column by column. And again, if I ask one of my other questions, so if I ask it if this particular Sudoku grid is a valid grid, you will note that this is not a valid grid there. You're going to be able to see that there is some duplicates in the squares, as opposed to anywhere else. So you see at this bottom middle here, there's a double 9, for example. The rows and columns are okay, but it's this double square there. But if I go into something like Claude 3 Sonnet, for example, which is like one of the most powerful models there is, you're going to see it's going to get the wrong answer. There you go. And you can see Claude's came back and said it's a valid Sudoku grid. And the reason it's came back is it's not tracked the subgrids very, very well. I mean, the good news is, if I'm fair, if I just go to Flash Experimental and ask the same question, so even without thinking mode, it will get it. And this is critical. So these thinking modes only do well when they've got good chain of thoughts. And then the inference time, they can reflect a little bit more and check the answers. But you see there, in this case, because it's a well-known chain of thought that happens there, the base model's been trained on it, even the non-thinking version, Flash Experimental is actually going to get it. So these models are doing well. Now, what is even more fun, if I come back to the kind of Tic Tac Toe for a second, let's just put it back to kind of Flash thinking. And then I'm going to say follow the instructions. And then I'm just going to paste in this version. And you see on this one, it says, what's O's next best move? We're just going to ask that question and see what happens. Isn't that cool? So I put the text, the prompt is in the image. What's O's next best move? And then it said the best move is place the middle in the bottom middle square, right? Again, I mean, it's still messing up the position of the board, which is fine. That's a different problem. But the fact is, it can follow a prompt on a piece of paper. So this isn't just about the ability, I put the prompt in, here's an image. I can actually put an image there and then have the instructions on the piece of paper. And then it will interpret what's on the paper and follow that through. I mean, this is ridiculous stuff. It's very, very cool. Just to be aware, though, if I create a brand new prompt here and I don't give it an instruction, let's say I just paste in the image without saying something like follow the instructions, it's going to come back with an error. And it's going to come back with an error because it wants you to have some sort of text prompt to go with that. So just, again, something to be aware of. Alrighty, so we're going to move on a little bit more. This time we're going to play a game. We're going to play a game called Replace the Word. I stole it from a UK game show called House of Games. Awesome game show. And then the idea in this one is I'm going to give a phrase or a title or a question it should know the answer to. But if it's got the word love in the answer as a word or a subword, I'm going to ask it to replace the word with the word fish. So if I ask it a question, who played Julie James in I Know What You Did Last Summer, then rather than Jennifer Love Hewitt, I'd expect it to say Jennifer Fish Hewitt. And you can already see the problem here. So it says it understands the rules. Eventually, after a little bit of prompting, it says Jennifer Fish Hewitt. So I'm going to ask it who is the world's first computer programmer. And you see what's happening here? It's kind of missed the game. It's got Ada Lovelace there, but it's forgotten about the game. We'll just say we're playing the game still. I don't know what's going on. So it should have came back with Ada Lovelace in this case, but it's came back with Ada Fishface. I don't know why. So you can kind of see it struggling a little bit. Whereas obviously if I go to O1, I'm not even going to go to O1 Pro. If I ask the same question, you can see that O1 is going to solve this and it's not going to have any problems figuring this out. So there you go, Ada Fishface originally, Ada Lovelace. And so its reasoning is pretty good, but Flash obviously isn't doing as well as O1 in this case. And again, I can ask it other questions. Again, you're going to start to see it's going to start to struggle in some of these problems. So I'm going to ask it, say the answer is hidden in the question. This is not a cheat sheet before bed. Am I right? It should recognize the word Edam there, but you see it's just struggling. But if I ask the same question of O1 Mini, you can see it's worked out Edam is within there, and it even shows you that the letter Edam is there. So this isn't a size of model problem, although it will do better with a larger size. I just don't think Gemini Flash has seen those types of puzzles before, whereas O1 obviously has. And again, when it gains better chain of thought, it's going to do much, much better. I think for the multimodal image issues, then probably a larger model is going to help that out there. Now, I did say this model was awesome at coding, and it really is awesome at coding. So I'm going to go and give a couple of examples and then we'll move on. So one of my favorite questions is to go and create a React app that gets latest time from an internet time service and update the time every second with real time from the internet and keep it in sync as much as possible. And I don't want it to use external dependencies. And what I'm meaning by that is that I want you to kind of use native JavaScript in that sense. And then, so effectively I want you to use fetch. And then, create an AI-generated donkey using SVG, and the donkey should be able to blink every time a second changes. So it's quite a complicated problem, but it should be, here's a clock updating with the internet clock, and then the donkey blinks in time with it. Okay, so it's generated the code there. It seems to have a picture of a donkey that blinks, etc. So let's just copy that to the clipboard. I'm just going to paste that in. It's looking pretty good from a code point of view. You see it's using the fetch as I wanted it to do. It's using world time APIs. It's API call. It's got a picture of a donkey. Now if we just do a bun run start, let's see what it comes up with. That is not bad. So you see the clock is going. It's updating real time. It's blinking. We can argue about this being a donkey or not, but you know what? Nothing else apart from Claude has generated a decent looking donkey, so I think this is okay. So if I ask the same question of Claude for a second, I'm not going to paste it into my workbook because it should be able to pick up the workspace and we'll be able to see what its donkey looks like. See what I mean? I kind of prefer Claude's donkey. I mean, none of these models are producing the best donkeys in the world, but it's pretty good, right? To run another test at the moment, this one is an interesting one. So it's a bit of a broken model here. So what I'm going to do is give it some code to extract some image embeddings. I'm wanting it to use GinaClip. A lot of the other models seem to struggle with this one. Usually it's the frontier models that get this right with reasoning, and then I want it to compute the similarities. So I'm basically asking it to fix this code up here and then calculate the cosine similarity. And you see here it's done an attempt at this. Let's see what it actually looks like. Just do a python test.py, and then hopefully it should generate the cosine similarity for those images. Oh, and that is interesting. So it's actually messed that up. Again, if I ask the same question, I'm going to use O1 Mini in this case. If I ask the same question of Mini should get this answer right. Let's run it one more time and let's see what the output of Mini looks like. There you go. It's got the cosine similarity between image 1 and 2, which is 0.72. So, it's failed there on the coding. It is actually quite a good coding model, but, it's not got everything there, and it's certainly not as good as O1 Mini. And the next one I'm going to do is I'm going to take an old basic program, which is called AC-Doocy, and then I'm going to ask it to rewrite this in Python. And again, a lot of models struggle with this. It's ultimately you have to understand the code, and then you've got to translate it into Python, and it's quite a complicated and large program. I'm hoping with Gemini having a fairly large token length, etc., and good at doing things like finding in the middle, etc. I think it should do a reasonable job of this. So let's see what happens. So it's generated the code. It's given us a decent explanation. Let's just copy this and then see what happens. So we'll copy the text. We'll paste it over. We'll run this one more time. Yeah, okay, it's running, and it actually looks like the original game. So we'll put a bet of 10. I lost. You know, it's got the logic there. The value's going down. I win a game, and then hopefully I will lose like any good betting game eventually. And there we go. Sorry, friend, but you believe what? And blah, 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 blah. So that works pretty well. So it's pretty good at code migration. It's understood the basic code, and it's done a really accurate translation of that game. So what would I say on this? I think of the reasoning models, this is probably one of the best reasoning models. Is it as good as O1? Is it as good as O1 Mini? Definitely not from that sense, from a coding perspective, but it's really strong. It's definitely better than DeepSeek R1. It's definitely better than QWQ. Yeah, the only thing that's beating this is O1, O1 Pro, and O1 Mini. The math capabilities are great, as you saw there, but that's not the thing that excites me about this model. The thing that excites me the most is the multimodal capabilities. I think it's got a way to go. It's not quite recognizing everything from the image embeddings, but again, it's going to get that over time. But the capability, as you see, once that starts to get accurate, is going to be incredible. And it seems to be the picture-y stuff, like the puzzle stuff it's struggling with, like the pictures of Tic Tac Toe, the pictures of kind of Sudoku boards, etc. What it's not struggling with is text, because you saw in the math samples, I could just copy in a workbook and then it was able to answer every single question word by word. And I think it's incredible. So well done, Google, Gemini Flash, thinking mode. What a great model. I think there's some great stuff to come in the future there as well, but what a great first attempt. Anyway, I hope this video has been useful, and I'll catch you in the next one.